Okay, here is your video for Learning Target 3, Solve a System of Equations Using Substitution. So in previous learning targets, we've worked with solving a system of equations by graphing, and now we're going to do it just algebraically. And the first way to do that is the substitution method. So here are the steps for how to use the substitution method. Okay, there's 4 steps, and they probably be a little bit confusing just right at first until you see kind of how they're used, and then hopefully that'll be a little clearer. We're going to go through and practice them with each of these examples. Okay. If you need some extra space, like if you don't have enough space on your note sheet, you can just grab an extra sheet of paper, pause the video, grab a sheet of paper, and then just bring it with you or attach it somehow to your notes too if you need a little more space. So if we refer back to our steps for a second, substitute the expression into the other equation. So we've got this x equals 7 right here. That is already isolated for us. Okay, we already know what x equals. Now I'm just going to take it and substitute it in right there for x. Okay, so that's the actual substitute step. I'm taking x, which is equivalent to 7, so I'm just putting in a 7 instead of x. So 2 times 7 plus y equals 5. And then this is just a simple two-step equation. We all know how to solve this. So 14 plus y equals 5, and y equals, if I subtract a 14 from both sides, -9. Okay, so that means that our solution to this is the point 7, comma, -9. And if you wanted to check that by graphing x equals 7 and graphing 2x plus y equals 5, you would get this, this solution for where those two lines cross each other. Okay. In this next example, again, we have x isolated all by itself. In this case, though, x is equal to 2y. So we don't necessarily know what number x is equal to, okay, but we know that it's equal to 2y. So I'm just going to take this equivalent expression. Remember, x is the same exact thing as 2y, except just written a little different. I'm going to take that and substitute right in for x. So I'll get 2 times 2y plus 8y equals 1. Simplifying a little bit, you get 4y plus 8y equals 1. That's 12y if you combine like terms, equals 1. And y equals, divide each side by 12, y equals 1/12. Okay, so now we know what y is for the solution. So our solution here, the y coordinate is 1/12. And I can figure out what the x coordinate is now just by substituting 1/12 into this equation. You can do it into either equation. If you wanted to sub in this 1/12 up here, where it says 8y, and you wanted to put in a 1/12 right there, you could. I'm just going to choose this one because it's easier, because x is already isolated. So I've got x equals 2 times 1/12. 2 times 1/12 is 2/12. 2/12 is the same as 1/6. So my x coordinate for the solution is 1/6, and the y is 1/12. So I can write it like this. Okay. Here are a couple more examples. In this case, we have an expression that's equivalent to y. So now we have y isolated. And we know that y is the same thing as 5 minus x. So I'll take this 5 minus x and sub that in for y right into that second equation. So we'll get 1 equals 4x plus 3, and then I'm going to put parentheses because it's 3 times this whole thing, 5 minus x. So we can go ahead and solve this for x. X is the only variable we have left. So 4x plus 3 times 5 is 15, minus 3 times x is just 3x. So we'll get 1 equals 4x minus a 3x, combining like terms, we get a 1x, and we're left with a plus 15. I'm going to subtract 15 from both sides, and again, this is just solving equations like we've done plenty of. Negative 14 equals x. So I know what x is in the solution. Now I need to figure out what y is. And I can substitute it in here. So we'll get y equals 5 minus a negative 14. 5 plus positive 14, and y equals 19. All right. Over here, we have y isolated in both cases. So we can take either one of these and substitute in to the other expression. So I'm going to choose this one, and I'm going to sub this into the other expression, or the other equation rather. So y is equal to 1.5x. So I'm just going to, instead of writing a y there, I'm just going to write a 1.5x. That's equal to 12 minus 2.5x. So now I just go through and solve. Plus 2.5x on that side, plus 2.5x on that side. This gives us a total of 4x equals 12. And divide each side by 4, and x equals 3. So 3 is the x-coordinate for the solution here. I'm just going to go ahead and substitute that back into the original equation. Y equals 1.5 times x, which we know is 3. And 1.5 times 3, y equals 4.5. So our solution is 3, 4.5. Okay? There are some special cases that if you're going through and using substitution and something kind of starts to not look right or not solve the way that you're used to, there are some special cases like that you'll notice. So if we start looking at this one, we'll just go ahead and start to try to substitute, and when we get to something that's a little bit strange, we'll talk about what that means. So we've got this first equation isolated for y already. So we know that that means 3x minus 7 is the same thing as y, equals y. So I can substitute that in right there for y. So that's my first step. Go ahead and do that. 12x minus 4. Instead of y, I'm just putting that 3x minus 7 equals 10. And we end up getting a 12x minus a 12x and then plus a 28 equals 10. Okay. If we start to combine like terms, we're going to end up with 0 x's over here. 12x minus 12x is 0x. And all that we're left with is 28 equals 10. Now, obviously, this is not true. Okay. 28 does not equal 10. So, since this is not true, and we've solved it, we've gotten rid of all of these x's, and this is all that we have left, and 28 is clearly not equal to 10. That means that for an answer for this, there are actually no solutions. So remember when we talked about graphing, and we graphed two lines that are parallel, that have the same slope, they never cross each other. Okay, so there are no solutions to that system. This would be an example of that type. So if we were to graph these, we would see that they have the same exact slope and are parallel, and therefore will never cross each other. So there's never a point of intersection, and there are no solutions, and we can verify that algebraically now. Okay. The other type of special case is right here. We'll look at this one. So we've got a one equation that's already isolated for x. So I'm going to take that x and practice substituting in right there. And I'll distribute, and I'll get 8y plus 6 minus 8y equals 6. If I combine like terms here, 8y minus an 8y, I just have 6 on the left and 6 on the right. And this is true. So we've eliminated all the y's, but we got a statement here that is true. 6 does equal 6. So what that means is that the answer to this is actually infinite solutions. Okay, you can plug in anything you want for x. These end up being the same line if you graph them. Okay, so 6 does equal 6. So we say there are infinite solutions. Okay, or these lines intersect at an infinite number of points. Okay. So those are the two special cases. Your before class is solve this system using substitution. Okay, so you've got one equation that's already isolated, substitute it into the other one, and go ahead and solve it and bring the solution with you to class.